Section 8.1, complex numbers. So we have this imaginary unit I. Now I is equal to the square root of -1, and I squared equals -1. So we're going to use these ideas all over this section. So another thing we're going to talk about is complex numbers. Now imaginary numbers are complex numbers, but we're going to talk about complex numbers completely. Okay, so it says if A and B are real numbers, down here, then any of the form A plus BI is a complex number. And a complex number, A plus BI, A is the real part and B is the imaginary part. So when we talk about the real part, we would just use the number A here. And when we talk about, the real part, we talk about just A there. And when we talk about the imaginary part, we don't really talk about the I there, we just talk about B being the imaginary part, whatever number that would be. And as we go through these more in detail, you'll see what I mean. So that's the idea there. And also we have this other idea here, down below, which is here. All right, this says if A is less than 0, then the square root of -A is equal to I square root A, and that's a positive A there now. So essentially, what happens is, this is the idea. Now, this isn't legal in Mathland yet, but the idea of where this comes from is right here. So they're saying that square root of -A is equal to the square root of 1 times the square root of A. Technically, we can't do that mathematically, so that's why they have to give this to us. And we know the square root of -1 is I, and we know square root of A is A. That's where this idea comes from. So we need this in order to deal with these complex numbers, a lot like we've done everything else. So we can deal with these algebraically now because of this property here. This helps a ton. So now we're going to get into a bunch of these types of problems. But before we do, we have one more idea I just want to show you. So here it is. This kind of just gives us a nice idea of where all these numbers we dealt with were and where these complex numbers lie with those numbers. So now initially we start off with natural numbers down here. And that's all my counting numbers, not including 0. So now where whole numbers is, that's here. That's all of those, and natural numbers is inside of that. And that's what I want you to see here. So the whole numbers are the counting numbers, including 0. That's why we just see a 0 here. So these sets here are almost the same sets, except the whole numbers has the number 0 in it. Now integers, we all know, are negative and positive counting numbers. So that's why the whole numbers are inside of the integers. So that's why we see that, because the whole numbers are 0, 1, 2, 3, all the way up. Integers are all of those, but plus the -1, -2, all the way down. Now rational numbers are fractions, and we can think of every integer and we can write it as a fraction. That's why it's in the rational numbers. Whole numbers we can write as fractions, and natural numbers we can write as fractions. So that's why all of those numbers, integers, whole numbers, and natural numbers, are all inside of the rational numbers. And now take a look at this. Next to it are the irrational numbers. And we see pi in here. E is another one. That's kind of a cool number. That's 2.718, blah, blah, blah. But that's also an irrational number. So those are not rational numbers, because irrational means not rational. So that's why those are in different sets. Okay, and all of those things that we just talked about there are real numbers. So when we talk about real numbers, it's all of those, irrational and rational numbers. That's a simple way to say it, because that would encompass everything here. So now we're going to get into this idea of complex numbers. So non-real complex numbers are over here. Now, they said non-real complex numbers are over here. Now, they had to be specific with that, and they keep them separate here. And then they say pure imaginary numbers. And what they mean by this is numbers strictly with i's in them. And that's what all of these mean over here. But technically speaking, real numbers are contained in the complex numbers. Because if I look at a complex number is a plus bi. That's why they say here non-real complex numbers. So yeah, those would be over there. Or pure imaginary numbers, those would also be over here separate. Pure imaginary meaning they have to have I in them. And they don't have a plus a real part. And the other ones have a plus a real part, but also have an I in them. That's why they call those non-real complex numbers. But totally speaking, complex numbers encompasses all of these. Real numbers and non-real complex numbers and pure imaginary numbers. Okay, now next video we're going to get into some of these problems.